Let's do my number 57. I kind of messed up when I did the first video, so I'm going to use the same example that I have, although I have all the work, and I'll explain how we got to our answer. So you are trying to find, on number 57, you're trying to find absolute max and absolute min. This is a continuous function. 2 to the x is a continuous function. Sine is continuous. So when you multiply those two, you get a continuous function, and it's on a closed interval. Therefore, it must have a max and min, and you have to know max and mins occur at critical points and endpoints. So to find the critical points, we need the derivative. Well, product rule, you leave the first alone, and you take the derivative sine, which gets you cosine. Then you take the derivative of the first, that's an exponential function, just like e to the x, so I am my own grandpa, but you times by the ln of the base. And then you leave the second one alone. Now you will notice there are a couple of common factors. Not a couple, just one. So I factor that out. So if I take that out, I'm left with just cosine. If I take that out, I'm left with ln 2 sine x. So that's where that comes from. Well, how do you solve an equation? Because this is equal to 0, because we're trying to find the critical points, so it's when the derivative is 0. So we have two factors. When the first factor is 0, it doesn't matter what the second one is. 0 times anything is 0. And similarly, when the second factor is 0, if that equals 0, it doesn't matter what the second one is. 0 times anything is 0. So here we have the two equations we're going to work with. Now here's where your knowledge of graphs are important. When does this equal 0? Well, if you know 2 to the x is exponential function, looks like that, it never touches the x-axis. Therefore, it never equals 0. This one has no solution. The other way you could have done this is taken log base 2 of both sides to get rid of the 2. So I could have log base 2 and then log base 2 of 0. The log and the exponent base 2 cancel, and we get x equals log base 2 of 0, but the log function does not exist at 0. So similar to the previous one, what does the log function look like? It looks like this. And what is the log at 0? Well, it never touches 0. It doesn't exist. It's not part of the domain of the log function. Therefore, that does not exist. So either way you look at it, that has no solution. I'll erase all this stuff. This has no solution, never happens, therefore there are no critical points there. Well, the second one is kind of a mess, and how would you know to do this? Kind of through experience. You want to solve for x. I can't do anything with this, so I'm going to subtract the cosine from both sides, and I believe, am I missing a minus sign here? I should end up with a minus cosine, okay? Because I subtract cosine from both sides. So I'll get a minus cosine here, that one's gone, and I have this equals minus cosine. And here's the trick, you're going to divide both sides by minus cosine, or just by cosine. Yeah, you're going to divide both sides by cosine. Why? Because this will get you just 1, and there's the negative from there. But sine over cosine is tangent. Okay? But you're trying to solve for x, so you want to get rid of ln 2, so you divide both sides by ln 2. Those will cancel, and you end up with negative 1 over ln 2. Let's keep going here. How do you get rid of tan? Arctan. You inverse tan both sides, and you should know inverse tan and tan cancel each other out. So you're left with x, and then you have arctan of negative 1 over ln 2. You just pop that in your calculator. You ain't doing that in your head. And you get this answer. Now here's what's weird, and you got to be careful. Negative 0.964, this answer here, it's somewhere in the fourth quadrant. you just go negative. So this is negative 3.14. So about 3 radians exist here. So this is about -1. So you go about 1/3 the way, roughly. And you have that. But if I were to rotate around this pi, so if I jump over pi, if you know the unit circle, this angle will also have the exact same tangent. So there's a second solution here, and it's going to be, let me go a couple more decimal points here. -96468. So this will be -0.96468 plus pi. Now, if I go again a half circle, or add pi, I'm going to be at -0.96468 plus 2 pi. So I have multiple angles. I can keep going and going. There's an infinite number of angles, but here's what we look at. We have a limited domain. It's from -2 to 6. Okay? -2 to 6. Well, this is inside the -2. This, what's that? 3.14 minus 1, so 2.14. So that fits. Now, is 2 pi minus this less than 6 or greater than 6? So 3.14, double that, 6.28. 6.28 minus about 1, 5.28. So that's also going to fit. So we have multiple critical points. So we have our first one here. We add pi, we get our second one. We add pi again, and we get a third one. I didn't do that in my calculator, but I can give that to you. Let's see, this is 57. So that last one, well, actually I don't have it for you, but just know that there's that third one. So we have found these 3 critical points. And remember, this one didn't count. So our final solution, where do max and mins occur? They occur critical points and endpoints. Well, the left endpoint is -2, so we need to find the y value at -2. The right endpoint 6, we need to find the y value there. And then also they could occur at a critical points, so we need to find it at the first critical point. And then the next one we added pi, so let me do it this way. Instead of writing out the new decimal. And then the third one, we added pi twice. So I'm just going to put 2 pi. And I'm going to cheat here and just get the list of y values, because I have it here written down. And here we go. Let me move this book over here. So at -2, the approximate value of our function, remember we're trying to find the y value of the function, so we're looking at this equation. We're plugging it into this equation here. Let me copy and paste that down here so you know where it's going. So we're plugging it in -2 here and here, and what does that give us? That's going to give us approximately -0.227. Then we plug in that number for these two x's, and that will get us -0.421. Then we're going to plug in this here and here, and that will get us 3.716 about. And we have 2 more to go. We're going to plug this thing in for x and x, and that one will get us -32.797. And then finally we plug in 6 here and here, and when we do that, that'll get us -17.883. and that's approximate. So looking at these values, we are trying to find the absolute maximum and the absolute minimum. Well, the maximum is going to be the biggest one. Which one's the biggest? To me, is it that 3.716? This would be the maximum value. It occurs at this x value, and the minimum value is the smallest. Looks like negative 32.797 is the minimum value. It occurs at that x value. So that's the end of this problem.